Lesson 2.5, Solving Equations Involving Absolute Value. The absolute value of a number is the distance between that number and 0 on a number line. The symbol for absolute value is 2 bars that are longer than the actual numbers or variables. So the symbol used for an absolute value is where you have the enclosed variable or the enclosed number or expression within 2 bars, and these bars are longer, slightly longer than the actual number or the variable. So for example, if I wanted to write the absolute value of 4, it would look like this. The absolute value of 4. The absolute value of x would look like that. And the absolute value of, let's say, x minus 4 would look like that. Okay, let's practice evaluating expressions with absolute value. Okay, evaluate. Let me give you an expression including an absolute value. 23 minus the absolute value of 3 minus 4x. I just want to make sure that you understand those are absolute value bars. So 23 minus the absolute value of 3 minus 4x. Okay, so I have 2 problems here. Number 1 is if x is 2, and number 2 is if x is negative 2. Well, what we need to do is we need to go ahead and substitute in each case, number 1 and number 2. So let's start with number 1. So I have 23 minus the absolute value of 3 minus 4 times positive 2. All right, the absolute value bars are a grouping symbol, so we need to work within the grouping symbol first, and the first operation we will do is the multiplication. So let's go ahead and write it down and do our first operation. 23 minus the absolute value of 3 minus 4 times 2 is 8. All right, the last thing we have, or the next thing we have to do is, of course, continue working within the absolute value bar since it is a grouping symbol. So let's do that. 23 minus 3 minus 8 is negative 5. And now we can evaluate the absolute value. Absolute value of negative 5 is asking me to say, well, how many units away from 0 is negative 5? And the answer is 5. So I'd have 23 minus 5, and 23 minus 5 is 18. So my solution is 18. Okay, now let's do scenario number 2. What if x is negative 2? We have to substitute negative 2 for x. Let's try that. 23 minus the absolute value of 3 minus 4 times negative 2. All right, 23 minus the absolute value of 3 minus negative 8. Okay, 23 minus 3 minus negative 8 is the same as 3 plus 8, which is 11. Now I evaluate the absolute value of 11. The absolute value of 11 is 11. So it's 23 minus 11. And 23 minus 11 is 12. Okay, let's continue. In solving absolute value equations, when solving absolute value equations, 2 cases must be considered. This is extremely important. You must always consider that there are 2 possibilities when solving absolute value equations. Case number 1 is when the expression inside the absolute value symbol is either positive or 0. And case number 2 is when the expression inside the absolute value symbol is negative. Okay, let's look at example number 2. Please write this down. We have the absolute value of y plus 2 is equal to 4. The absolute value of y plus 2 is equal to 4. Well, let's think about that. Whatever is within the absolute value bar, in this case, this expression y plus 2, must be 4 units away from the number 4 on a number line. If you consider that possibility, let's look at a number line and explore this. Here is 0. Y plus 2 has to be 4 units away from 0 because its absolute value is 4. But there are 2 possibilities, right? There are 2 numbers on our number line that are 4 units away from 0, and that would be positive 4 and negative 4. So because there are 2 possible values for the expression y plus 2, we set up 2 separate equations. So case number 1, y plus 2 equals positive 4, or case number 2, y plus 2 equals negative 4, and we will solve for both. Okay, so let's start with case number 1. In order to solve this equation, y plus 2 is equal to 4, we'll subtract 2 on both sides. And we have y can be equal to 2. In case number 2, again, we will subtract 2 from both sides. And our solution is y is equal to negative 6. So we have 2 possible solutions. In this case, y can equal, and we will always put them in a set notation, and we'll order them from least to greatest. Negative 6 or 2. Those are the 2 possible solutions for y. Okay, let's continue. Here we go. Number 3. The absolute value of 3n minus 4 is equal to negative 5. Well, let's think about that. Picture a number line with me. And we want to know what numbers have an absolute value of negative 5 or are negative 5 units away from 0. Well, you can't measure distance in negative numbers, so automatically I know this problem has no solution. The absolute value of an expression, of a variable, or of a number cannot be negative. Okay, number 4, jot it down. The absolute value of n plus 7 is equal to 5. I will take just a moment to draw a number line for us. Remember that absolute value of n plus 7 is saying the distance from 0 of that expression is 5 units away from 0 on the number line. And we know there are two numbers that are 5 units away from 0. And that would be positive 5 and negative 5. So we'll set up 2 cases, 2 scenarios. N plus 7 is equal to positive 5, or n plus 7 is equal to negative 5, and we will solve for both. Okay, let's go ahead and do that. Subtract 7 here, and n would be negative 2, or subtract 7 here, and n equals negative 12. So Remember that I will write down my solution in a solution set, and I will order them numerically. So negative 12, comma, 2. Okay. All right, number 5. On your own, let me pause the video for a moment while you work on number 5. Come back and check your answer. Number 5 has no solution. Well, clearly, there are no numbers whose absolute value is negative 8 because distance cannot be measured in negative numbers. Absolute value is never going to be negative. Okay, number 6 and number 7, you will work out on your own. Go ahead and pause the video. Come on back and check your answer. Okay, for number 6, the solution is negative 6, negative 2. And for number 7, the solution is negative 2, positive 4. Go ahead and check your answers. Make sure that you show the steps correctly for each one. And let's move along. Okay, to write an absolute value equation given a graph. Let's suppose we're given this graph right here. And there are two numbers that are your solution, the number 10 and the number 16. You will use the following format in order to write your absolute value equation. Okay? Absolute value of x minus the midpoint, the number right in between those two solutions, in this case 10 and 16, is equal to the distance of each solution from the midpoint. So let's look at this one and see how we would write this equation. So x minus the midpoint. Well, what is the midpoint between 10 and 13? And the answer there is 13. So 13 would be my midpoint. So x minus 13 is equal to, and then from the midpoint, how many units away from each solution is that? And it would be 3. So that's how I would write an absolute value equation if I'm given a graph. Use the pattern that I've shown you here. Absolute value of x minus midpoint gives you the distance from the midpoint. Okay? All right, now for some extra work at home. Just a few problems that I want you to do to practice a little bit. 3 and 4, where you are evaluating each expression if r is negative 2, n is negative 3, and t is positive 3. Okay. And then here, solve and graph. So I want you to solve each equation and graph the solution. So that's 1, 4, and 8. And then lastly, I am going to let you try one where you have to write the equation. So go ahead and try number 13. Write the equation involving absolute value for each graph. Okay, don't forget to write down any questions you might have. Be ready for tomorrow. We'll go over those. And be ready for a possible quiz. Thank you. God bless you. Have a great night.